Alright, today we're going to be going over Cuckoo. The version that we're going over is the latest from their GitHub as of 3 days ago, so it's 2.03. Usage statistics are a little bit weird. Just go over that real quick. If something is running or is waiting to be run, it'll go under running and pending. Total is how many in the system, so if you're running 20, it should say 20. Completed is how many have been analyzed. Reported as the final number, how many have been done through the process and reported on. Some windows that we have open here is malloc. This is used to store PCAP analysis. So while we do traffic dumps on data that's going to different websites or IP addresses or servers or services, we need a place to long-term store that out in a way that's workable. So that's what we use this platform for. And then we have MISP, and this one here, I'm going to refresh, and it's going to ask me to log in probably. Yeah, it does. Hold on, let me log in. This is a threat management information sharing platform. You can create a lot of different user accounts. You can have different systems injecting software in here. You can look at events. We have none in here right now. We'll get some when we run this malware. But this is what we would use to basically give us a high-level overview of what was going on in the system. Cover more of these later on. This was an interesting piece of viral I found. It's detected by the top few on this list, but no one below. So Malwarebytes didn't pick it up. Here's the actual screen at VirusTotal. Just wanted to show you this. Malwarebytes did not pick this particular file up. Now this isn't the one that we're running right now. It's just something I wanted to show you. Our system is kind of integrated. We only ask them, hey, have you seen this? If they have, we get the data. We never send them payloads. So let's go ahead and get started here. So we're going to select the malware that we want to run. We're going to run the WannaCry one. This is going to encrypt our little system. Wait for that to upload. Sometimes it seems like I have to select this twice, which is A-OK. Go select it twice. There it goes. All right. Here are the options. First of all, you want to make sure there's a blue box beside the payload. You can have multiple here. I could have selected 5 or 6 files, but I only selected one. If you have some files that are the same file, but they just rename stuff, this will tell you to be in red, and it'll say duplicate. But, all right, so we have this one selected here. Now, we're going to give it internet access because we want to see if it talks anywhere. The packages and priority, just leave those at default. Timeout. Okay, so this is going to let it run for 120 seconds, like 2 minutes, right? Options, we want to do enable injection. We want that. We want to get memory dumps. We want a full memory dump to use in Vitality and analyze that further later on. We are going to enforce the timeout. We're also going to enable simulated human behavior. Leave that there. We can add extra options here too, by the way. For the machine type, we're going to run this on our Windows XP, so we're going to select that one. With all of those settings, all good, over here it should say 1 of 1. Click Analyze. You'll see that our virtual machine is now starting out, and I'm just going to move this over here so you can watch kind of Cuckoo run as it's doing what it's doing. Now, like I said, multiple payloads can run, but I have them set to run one at a time. So I'm only allowing one VM to start. I'm inside another VM. I'm using VirtualBox with inside of VMware, basically. So I don't want to tax my system that much. On a normal lab setup or something like that, this would be on a server where you are integrated correctly into it. And you could run more than one, whatever the resources would allow. Cuckoo is also has the ability to do basically batch jobs. So if you had, like I do, Windows XP and Windows 7, and you had multiple VMs allowed to run, if you sent 15 payloads to, Once one VM is free, it's going to execute that payload on that VM. So let's say that Windows XP is your first one. And you can see it's encrypting over here. So we'll just kind of click on that so you can watch that while I talk. So let's say Windows XP is your default one. Your first payload gets triggered on Windows XP, and then since Windows XP is now busy, your second payload will go to Windows 7. And let's say Windows 7 got completed before the Windows XP payload, the next payload would be run on Windows 7. If Windows XP freed before the next Windows 7, the next payload would trigger on that one. And they just keep basically whichever one is free. Now you can do like 7 of these and just start chewing through payloads, but for this, like I said, we're only doing it one at a time. Some things that are going on over here on Cuckoo is there's an order process. So the process is analyze it first, which is what we're doing right now. We're letting the malware run and collecting what it did. After that, we're going to process it. We're going to process the network traffic. If we could man in the middle it, we are going to look at the memory that usage that's going on. Did it call API strings? All of these things. You know, APIs allow malware to do things as well. So we'll track all of that. How did it change the operating system? Registry entries. Process trees. You know, what processes were started by what applications to do what it did. All of this thing I'll show you in the reporting section, which is the very last section that's going to be run. So when you see the virtual machine close out, now in the background you see that this moved to completed. Okay, so that part is done. If we come over here to the dashboard, you'll see that it is completed. We have 1 in the system. However, reporting is still 0. That's the part that it's going to work on now. You can see as it's coming through here, it's doing these memory dumps. Vitality is, you know, basically ripping apart those and matching them up and organizing that for later use. Now this part's going to take a couple minutes to run. This is probably the longest part of the process. A couple interesting notes. With Vitality, we're using 2.6. Okay, this is installed into the user virtual environment. So there's Yara and Vitality. Vitality comes with a number of dependencies. However, building Yara, we only need the source files there for Vitality to work correctly. With the dependencies, we pip install them. We do not pip install Yara though. We actually just want the source there, so that when we build Vitality, it has it. With that running, like I said, we're using Vitality 2.6. Our Python versions are 2.7, just to give you a little bit of background about how the system is built. The threat portal MISP is basically inside another VM all by itself. That is an Ubuntu server. So that is isolated and runs alone. The Molot server is integrated in with the Cuckoo server, so its web interface is on that machine. This part, like I said, is the longest part. All of this brought back together, though, you can find some exciting things if you can get payloads and process them fast enough. There are ways that we can run payloads, get our output, and then reset Cuckoo back to basically clean it out, blank, and then run more. That helps deal with some of the disk space issues. However, with the Elasticsearch, the only thing that we can do in malloc is reinitialize the database, which is fine. MISP is a 100 gig virtual machine, and it should hold for quite a while. We may have to do some data pruning down the road, but nothing really as of the first year or two that I can foresee. It really depends on how much data is stored there versus the Cuckoo or any of the others. And it's dynamic with every payload. It's always going to change. Ways that we can improve these systems are by using Thug, client honeypots. We can get lists of bad domains and bad actors. We can pull them from here and send a phony web client to those sites to be infected or download different types of malware to automate through the Cuckoo API system. Cuckoo allows us to submit samples to it through a unique web API or a file API on the server. This system also has the scripts installed to pull data from the honeypots directly that we have throughout the world. These honeypots basically are getting payloads all day long. However, a lot of the payloads they're getting are duplicate, especially in the same machine. But what we see is that it's named differently. Same file size, we detect it as the same thing, but it is named differently. Not really a whole lot we can do about that. On the screen here, we've moved to a different section. Now we're looking at network traffic. We're using the Seritica. So we can see that's going through and it's doing the PCAP. It's doing that portion of the analysis. This part runs fairly quick. It's working in combination with Snort to label or apply signatures or rules to it. You can see that some of the Cuckoo rules are saying that we're not really totally compatible with all of them. That's something that's been coming from the Cuckoo community clone, and I hope someone's going to update that soon. I don't know exactly if it means those modules aren't matching or if those signatures are irrelevant, and there's no real clear way to get a count over total signatures at this time. So those are future things that we can look at. Here we go. Now we're seeing the thread exit for that. Now we're into the reporting phase. This is where it's taking all of that data and saying, hey, can we extract anything out of it that we can let the user know about? And this, like I said, is the end of the running of the malware. And it's one of the biggest portions. This is kind of why we ran the malware to begin with, other than the fact of watching it kind of encrypt the machine. So here in blue, we see task procedure completed. And that is completed. I'm just going to pull it on the screen. So if we refresh this page, now we see that this is now reported. Go over here to the recent tab. Quick note. These are sorters. So basically files that you've run that have a score 0 through 4, 4 through 7, 7 through 10. You can filter out the rest of things you don't want to see. By default, we've only ran one. It's the WannaCry. You can click on any of these to go to the report. So we'll let that load up. So this is a dashboard for the report WannaCry. Okay. Over here, you got the name in the right-hand corner. You got the score below that in red. It says it's 18.2 out of 10. It means it's really bad. Got some file descriptors here. Tells you the SHAs, any YAR or SSD rules it matched. It was a Windows XP machine. We got Cuckoo log here. We got the analyzer log here. Signatures, things we've matched it to. So we see a number of things like, did it query the computer name? Yeah, I did. Close that back up. Did it use Windows APIs to generate cryptographic keys? Yes, it did. There's memory addresses for that. The executable used a GNOME Packer. Uses Armadillo version 1.71. Did it start servers listening? Yes, it did. It opened up all these sockets on all these ports. Or port 0, port 0. We got backlog. We got 1119 there. So these are all different ports that you could use in different things to help identify WannaCry. So I'll close that back up. Some of the more interesting things are down here in the red, which is listed below. Modifies boot configuration settings. And there's the actual command that it listed to do so, hence the quiet, suppress, hide. Found Tor-related URLs. So here's where it's trying to get the Tor Windows client so it can communicate. Appends a known WannaCry, ransomware file extension to files that have been encrypted. There we are, right there. So you can see that you can get a lot of stuff from this. I mean, all the way down to, and there's screenshots, by the way. Click this button to expand if there's a lot. You won't be able to see them. It only gives you like blah. So you can see it here, doing its thing. This little sideboard is all of the independent parts. That's what that's there for. If you're only interested in certain things, you can jump. Like, let's look at behavior stats. Here's the process tree. Here's all the processes started, what it called. You can see how this ransomware deployed itself. It's pretty good to know if you're going to do like memory forensics, if you're trying to develop additional software to deal with these kinds of things. Again, this is just one type that executes one way. There are many different variants of strings coming out that we see every day. Let's see. So the VM memory dump, load that up. And some of these could take a little bit longer to load than others. You know, they have a lot of data in them. You know, here's things that we were able to pull out, like, you know, PIDs, running processes, things, services it tried to invoke, kernel modules here as well, device tree, you know, what did it see? You know, SSD connection information, you know, right there. Yara scan, didn't really pick up anything. Callbacks, I mean, there's tons of good stuff. Sockets it opened, what port, what protocol, what IP. It's all great information. You can compare one analysis versus another here, and then you select or search and pull up a second one. And you can see if you have the same thing, did it change? Export analysis, this is the bigger part. So this one right here is about 189, 84.9 megs. Some analysis can get kind of heavy, especially 300-400 megs per analysis. That's used through disk space quite a bit. Around 200, 250, 300 will fill around a 500 gig drive. There are ways to clear Cuckoo. You can run the Cuckoo space clean command. That will remove any data. However, it will not from the other two systems. Moloch will still have its data. We can refresh because we probably have data there now. Yes, we do. So before, this was all blank. This is all traffic that was created by analyzing the WannaCry. You have different views of the data. You can go through all of these on your own. Certs, you know, email, different kinds of traffic. All of this is matched to general. Over here in the events, we can see that we have a new event. Scroll all the way over to the right, and you can click the edit button, and you can view event. So we see this is a Cuckoo sandbox analysis. It was number 1, the owner who did it. You start looking at some of the data that was retrieved. The sample here, the SHA key, different IPs. So this is network activity. Talk to this address, this address, this address. Over here, you can, you know, pin and tag stuff. But this is for sharing this data with other people. Get insight over the data, see activity. You can see who's interested in what. You get different filters so you can cut down on what you're seeing. If you only see network traffic, you can click that one. Any financial information. Just different correlations, warnings. Feel free, I mean, to look through and experiment. But I'm not going to go over too much of this in detail. We'll cover other topics a little bit more in later videos. I just wanted to give you, right now, a little sample of what the new Cuckoo does, how things run. Thank you very much.